And I just heard the noon whistle here at Fort Atkinson, Wisconsin, which is my cue to say that this is Steve Larson, member of the editorial staff up here at Forage Dairyman, semi-retired. Glad to have a number of you with us out there today. We look forward to our topic, very timely, obviously, how this year's forages are going to feed. We've got some experience and quite a bit of lab data on that now. And so we're looking forward to that presentation, and we also want to thank our sponsor, QLF, Quality Liquid Feeds, for their support with the webinar today. And with those comments, I will introduce our co-host, Mike Hutchins, down at the University of Illinois, who's standing ready to introduce our speaker today. And we'll let you take it over, Mike.
Well, very good, Steve. It's my personal and professional pleasure to introduce Dr. John Gazer, who will be our leader of our webinar here today as far as that goes. I've been on several programs with John, and it's always a pleasure to share the podium with him. John grew up on a dairy farm near Plymouth, Wisconsin, and back in those days, John, I guess there was about 60 head. Now there's over 1,000 dairy cows on that dairy facility. John earned a Bachelor of Science degree in Dairy Science and Agronomy at the University of Wisconsin-Madison, and then got masters in both of those areas, plant breeding, genetics, and dairy science, and then finished with a PhD from the University of Wisconsin under Dave Combs. He spent several years in the feed industry, and now he started to work, or has started his tenure at Rock River Lab as one of the major forage testing labs here in the United States, and he provides a lot of technical support there as well. He also is an adjunct professor at the University of Wisconsin-Madison, which allows him to stay involved at the university as well. So, John, we are very pleased to welcome you to our Forage Dairyman webinar, and the program is yours.
Thank you, Professor Hutchins, and I'm somewhat surprised that you didn't necessarily hold it against me, that Wisconsin connection there. So appreciate that, and I look forward to contributing hopefully some great information and timely as we looked out to putting some content together for this webinar a few months back. Steve and myself getting the invitation to come in. It has come to fruition a little bit different than maybe I would have thought. I think we would have thought. So I see some questions coming in already, and we will get into that today. But we'll look at how this year's forage is going to feed, both from a nutrition and from an anti-nutrition standpoint. So moving past the title slide here, and being trained as a nutritionist and then having a family in the dairy industry, we work very hard to identify really the factors that are going to make a difference for your farms and help identify opportunities and hone in on where those might be so that you can make some decisions. But before going into some of the detail of what we've seen this year, some crop summaries, and then some of the anti-nutrition discussion towards the back half of the webinar today, I always like to reflect on, and again, because my family is in the industry, and I'm very interested in helping all of you find opportunities. And when I speak to opportunities, the most real opportunity we have is to improve health and performance. And so as we think about some of the content we're going to discuss and review today, how is this going to reflect back to your family or your dairy and your dairy business? Because we all need to be able to pay our bills at the end of the day, and that's a very real facet of what we deal with day in, day out. So one that I reflect on and I want to keep in mind. What I'd like to share is an email, a snippet from an email I get from Margin Smart, really no affiliation with Mark Linsmeyer and their group, but this was accessed on December 5th, so just last week. And why I appreciate this content is I get this every couple of weeks, and what Mark's team does is they'll offer a free newsletter every week, and based upon class 3 futures and then corn and bean futures, they will, and their team will project out margins for an example dairy farm. So this helps me understand not only where we are at currently, what you are all experiencing. When we look into the past, that's pretty clear as far as dairy performance, dairy profitability, but looking out to the future and helping me get an understanding of what maybe our mindset will be and what sort of opportunities there are going to be financially or as far as mailbox prices. It's nice to be able to reflect or I'm sorry, forecast out and look into the next 12 months. So what Mark's email does is it projects out between $0 per hundredweight margin and $7 per hundredweight margin. So as I think about this, if we get below this line here on the bottom, we are probably not all that happy. I've got a crabby family because we are not going to be able to pay our bills. But as we move up from here, then we're more able to pay our bills and potentially look at investing in the dairy in some other ways. So based on the last few weeks, I'm pleased to see that over the next 12 months forecasted here, we look to be between a little bit of a positive margin and maybe upwards of $2 per hundredweight. So I'm pleased to see that. If you follow here sort of the beige and then the red lines, I'm happy to see hopefully we're going to have profitable businesses looking out into the next year. But now moving towards the content today and starting to draw hopefully a couple questions in your mind when we're going to explore how the crop is going to feed. I want to bring us to hopefully a common understanding before we get into some of the detail. And so I'm going to show you here my family here, friends, kids as well. So this is my little daughter Lucy here and my son Sam, as well as some of my nieces and nephews, and then some of my friends' children. And then I have them all happily pictured here eating their lunch or dinner that we had on the grill for them. But then I've got them pictured next to dairy cows, and I guess there would be one comparison here that we could make. Both are eating, but yet both are going to be very different in the nutrition that they derive from the meal in front of them. So our kids here, it's pretty straightforward when, as a nutritionist, I think about how our kids eat and how they derive energy. Pretty consistent energy available from whether it be hot dogs here or some fruits and vegetables we put in front of them. Contrast that with dairy cattle. We put a TMR in front of dairy cows, and we do the best we can in projecting out the energy potential and how much milk or gain there might be from a total mixed ration, but we don't always necessarily understand exactly what we're going to get, or cows might respond differently. So why is this different? Both groups here are eating. Theoretically, the nutrition derived from the meal should be similar, but they're not. Why are they not? And so we're going to get into that. Continue and expand on the question I hope to put forth in the prior slide, and now looking at a case study here with a dairy that I used to work with and support. So this was a 1,200 cow dairy in northeastern Wisconsin, and we were feeding 2009 corn silage, and on the y-axis here we have pounds of milk per cow per day, which we were looking at this trend over time and tracking our performance. And we transitioned from 2009 corn silage to 2010 corn silage. And we made that transition, and I remember it very well. We had conditions that were very similar to what we experienced here in the upper Midwest and what we are experiencing in the upper Midwest in the United States yesterday and now into today and tomorrow potentially, if we think about Michigan and maybe some of the eastern states. But December 13th, 2010, we transitioned from the old crop to the new crop, and you can see here that we were humming along in performance. The dairy, we had increased in performance on 2009 as we made minor modifications within the diet, but as we transitioned cold turkey into that 2010 corn silage, you can see performance just dropped off a cliff, and we made some pretty substantial diet adjustments, unfortunately, that were spending a little bit more than I guess we would have wanted in feed cost in order to get our performance back to where it was prior to the switch. But why did this happen? As I look at just the fiber content, which I've described here with that corn silage, the 2009 crop, 43% fiber, and then in the 2010 crop was actually 37% fiber. So what diluted out the fiber was grain. There was actually more starch, more grain in the 2010 crop, which should have equated to more energy per ton, more milk per ton. But you can see the cows did not recognize that. We just tumbled off. And so why did this happen? Hindsight, it's always perfect. What we ended up doing was pulling forage out of the diet, pulling corn silage back by 25%, bringing in corn gluten feed and soy hulls to offset the poor forage digestibility to get our performance back. So understanding what happened with that herd, and you have likely experienced in the past, I'm going to draw an analogy here to a campfire. And this has been one of the better approaches I think I've found to describe what's happening with animal nutrition, what's happening within the rumen for nutrients. And by nutrients, I mean starch, protein, fiber, what our TMR is composed of. It's taken me a number of years to come to this point, so I hope you're able to catch up and run with me here today. But if a bit of this is lost upon you, I can certainly understand that, because this is a pretty complex phenomenon that's happening within the rumen. And thinking back to, again, what do kids, or how do kids and a pen of cattle differ, it relates to what we're going to discuss here. So what does this campfire have to do with digestion, and ultimately lack of digestion or nutrients that are passing out through in the TMR, or I'm sorry, in the feces? Here you can see some poor starch digestion, you can see some poor fiber digestion. Why are these nutrients getting through the cows? So when looking at fiber digestion, or starch digestion in particular, and with fiber digestion, we as nutritionists and some leading researchers in forage testing laboratories are starting to better handle and better model and formulate around some of these concepts. There are two components needed for building a really big, warm campfire. If we think about sitting around the campfire and we aim to sit there for 2, 3, 4 hours, have an enjoyable time with friends and family, roast marshmallows, what are two components? Think about two components we need to make this campfire really roar. The first being, we need fuel. So I think about the amount of wood in the fire pit, and I'll speak in these terms maybe a bit throughout the remainder of the webinar, but we can have a big old pile of wood like I've got depicted here on the left in a large split wood pile, or we can have just a little bit of wood. And so then it's pretty easy for us to, I think, conceptualize, well, we're not going to get much energy, we're not going to get much heat out of the fire pit that's only got this amount of wood relative to this amount of wood here. So that's reasonably straightforward. In nutrition terms, we are now using tools like UNDF240, which tells us how much fiber we have that's actually unavailable to the rumen. So UNDF240, very complex topic, but think of that as how much wood do we have in the fire pit. In the future, we're also going to be looking at and better understanding how much starch, how much of your grain, corn or barley or wheat is actually available to the rumen. We need to understand that. But that's not the whole story. Think about what else do we need to know beyond how much wood is in the fire pit. And the answer to the other aspect of our fire when we're putting together a good campfire and getting rolling is how fast do we burn through the wood, or do we burn through the fuel that's in the fire pit. And here, this is akin to nutrient digestion rate. So the amount of wood that's in the fire pit, that's how much nutrient do we have within the rumen, do we have provided by the TMR, but then we also need to know how fast do we digest through said nutrient. So here on the left-hand side, we've got quite a bit of wood here, but it's soaked, it's been through rains, or we haven't let it dry out. So despite the fact that we have a lot of potential, we're not going to be deriving much energy from this because it's quite wet. Whereas on the right-hand side, we've got some kindling broken down nicely, opening up the surface area, and very dry. And I think we all can understand we're going to burn through this pretty quickly, and we're going to get quite a bit of energy pretty rapidly out of this. But we also need a lot of wood there in the fire pit to make sure we have the most successful fire. So hopefully you can understand these two concepts, the amount of wood in the fire pit, how dry that wood is, to then think about how we look at nutrition within the animal. So after we know how much fiber is available for rumen digestion, then we can pair that up with how fast does that fiber break down, and then we can come up with an idea and an estimate of fiber digestibility combined with total fiber content, and then we can figure out how much milk we're going to get from the forage. So bringing this a little bit into hopefully a clearer picture, or looking at in the context of a forage analysis, when I'm scrolling through a forage analysis and I'm aiming to understand how cows are going to respond, and I'm going to project out how cattle are going to respond when we change forages. First, I'm looking at fiber and starch content. That would be akin to how much wood do we have in the fire pit. I'm going to consider UNDF 240, and then I'm going to consider the fiber digestion KD. Don't worry about that for today beyond what I've just described here recently. I just aimed to set the stage, but I'll tell you that Professor Combs at the University of Wisconsin has developed a nice tool that integrates both how much wood we have in the fire pit and how fast we burn through the wood, and helps us understand how much energy we can derive from fiber. And that tool is available, and it's called TT-NDFT. So it actually takes the fiber digestion rate and pool size and then gives us one single number that we can pretty quickly assess the fiber potential. We'll use that for the remainder of the webinar today. Here the goal would be 46 to 48, and that will be a forage that cows will do quite well on. The range here is less than 30 would be the really low bottom end, and the upper end would be above 50, and cows really have shown to respond nicely according to changes within this. From a starch standpoint, I really focus on how fast do we burn through starch. I will make one point that there are a number of different tools out there available for looking at starch potential. I'm going to focus in on an in situ starch digestion measure, one that has been shown recently to be in agreement with cows. There's some question. There's also an in vitro starch digestion, which is a lab bench technique that has been utilized within the industry. It looks like cows might not necessarily agree with in vitro starch digestion as well as they would with an in situ rumen digestion approach, where we'll actually take feeds and incubate those within the rumen of animals. That aside, the goal here would be to see greater than 80% of our grain utilized within the rumen, greater than 80% of our starch, telling us we're burning through that starch pretty quickly. And then lastly, after I consider the nutrition content of the feed or forage or TMR, it's important to think about nutrition robbers, and these will be unfortunate aspects to feed that come from the field largely, or may come from poor ensiling that we'll discuss later on. So we can have a really wonderful feed as far as a nutrition profile on paper, but the animals aren't able to derive any energy or anywhere near the energy that they should from that, and that's what I'm alluding to here. So we'll get to our first poll of the day here and post a question: how much milk is in 2016 forage relative to 2015 milk? Fairly straightforward here. Do you think there's more milk? Do you think there is less milk? Do you think there's similar milk as 2015? Do we think that the potential might be there but it's not delivering? Or do we think we have absolutely no idea because we haven't gotten into feeding it yet?
Well, Steve, what's your take on that out there at the Hordes farm?
I think at the Hordes farm we'd have to go with the last one, because we've had great crop years and we're still chewing through some of the past forages. So I don't really have an idea at this point whether it's going to be more milk, less milk, same milk. What are you hearing from the meetings that you go to, Mike?
Well, I hear cows are milking well. I just my hope is that there'll be more milk there. We've had just one whale of a corn silage crop here in Illinois. You know, we're seeing starches typically in the ranges of 35 to 40% starch. So there's an awful lot of energy from the starch, or at least some of that kindling, as John points out there. So I guess we're pretty close to getting our two-thirds. I think our Republicans are slower voting. I don't know. Maybe it has to do with that. Maybe Russia. It must be Russia. Russia.
Let's see what John has to say about what we've learned.
Absolutely. It looks like we've got a nice distribution here in the results. So looks like a number of you are seeing more milk. Some may be seeing less milk, unfortunately. A smaller portion seeing similar milk. The potential's there, but it's not delivering. Yes, unfortunately, we are having a bit of that as well, and some of you having absolutely no idea because we haven't gotten there yet. And so the responses here, the responses are very similar to what I may have respected, in that it depends on the region of the U.S. and as well as maybe even the region within the a region, if you will, kind of the microclimate, as to how cattle are responding. And so now let's get into and let's look at why your region or your area may be responding one way or another. There doesn't appear to be a conclusive up or down as far as performance this year. When I'm looking at just the fiber content in feed, understanding that fiber is really one of the big parameters that influences animal performance, and that energy potential, microbial protein out of the rumen, a lower fiber feed will be a higher quality feed. We'll have more energy because that fiber is being diluted out by protein or starch or sugar. So those always will carry more energy than will fiber. And that is one of the big differences between my kids and nephews and friends' children and dairy cattle. With humans, we get pretty consistent energy out of our feed. With cattle, very different energy out of our feed, and fiber is one component of that. So generally speaking, it looks as though we have lower fiber content across the eastern U.S., which is going to be a good thing. That's going to bring more energy. Lower fiber content within the Midwest, and similar fiber content within the western U.S. Here we're looking at neutral detergent fiber ranging between 30 and 50% of the forage dry matter. We're going to be comparing 2015 to 2016 on the x-axis here. The blue bar, and this will be similar across a few graphs to follow, will represent hay. The red bar will represent haylage, and the green bar will represent corn silage. These are summaries of Rock River Laboratory feed and forage analyses over the past couple of years, and we have offices from the east to the Midwest to the western U.S., Ohio, New York, specifically in the east, representing the east, covering New York, Pennsylvania, the New England area, into Indiana, Ohio. Midwest, covering Wisconsin, Minnesota, Michigan, Indiana, Illinois, Iowa. And then western U.S., we have an office in California representing the western U.S. there, the western dairy men and women. So generally speaking, less fiber, but you can see then a yellow bar here highlighting where if I am a dairy owner or somebody looking up to put up ideal quality feed, I would like us to have 40% or less fiber within our hay, haylage, and corn silage, assuming primarily legume hays and haylages. If it's grasses, this is going to be shifted up just a little bit. So we're getting to that mark with corn silage, which I think speaks to what Professor Hutchins mentioned before. A lot of grain, high starch levels, so that's a good thing. But it doesn't necessarily tell us exactly how much milk we're going to be deriving. I do want to make one comment here, and I want to make Mike Rankin proud. And just we tend to speak in terms of relative feed value, or RFV. You can see I have a strike through here. I would like to just point out that yes, we do speak in terms of RFV, and it looks to be similar across dry hay and haylage crops for the east, Midwest, and west, but I want to just point out relative feed value is not a good index to be comparing feed and determining how this forage is going to perform when fed to cattle. It just incorporates the fiber content. It does not incorporate that fiber digestibility, the kindling potential to that fiber, so I want to hopefully pull those of you away from RFV that I can and let you know that fiber quality here I'm depicting with total track, fiber digestibility, TT and DFD. Combining this with fiber content is a much better forecast for how forages will perform. So now understanding that TT and DFD is very similar to that campfire analogy and just a really good tool. It's an RFV on steroids if you want to consider it that. Professor Combs has great research behind this tool and showing us that it agrees with cows. Looking at now fiber digestibility, how fast we'll burn through that, looking at the eastern, midwestern, and western U.S., and then the various forages in the eastern U.S., we're seeing this fiber digestibility up substantially from 2015 to 2016 forage. Over the next few slides, I'll actually interpret this for us all in terms of projected milk production. Within the Midwest, up slightly. You can see up a little bit with corn silage for 2016 corn silage, but this is a little bit yet to be seen. And then the western U.S., fairly consistent from 2015 to 2016. So looks to be decent feed quality in 2016 relative to 2015, agreeing with what Professor Hutchins talked about before, how maybe there's more milk in this. When thinking about now projecting out production, I've gone through a couple scenarios here where putting my nutritionist hat on and putting together a theoretical diet using an average forage from 2014 now, as well as 2015 and 16, which I've shown averages here in those graphs. I've projected out what milk production potential would be out of those crop years. And so at 20 pounds of corn silage, 10 pounds of haylage, I've run these projections for the eastern and midwestern U.S. I've used 10 pounds of dry hay for our western U.S. You can see that there looks to be more milk, substantially more milk, maybe 5% greater for those of you dairying in the eastern U.S. Again, that's incorporating that nutrient content and nutrient digestibility, fiber content, fiber digestibility. So now we'll get to a question that we had ahead of the webinar today, and I appreciate the questions ahead because it gives us as presenters a chance to think and bring the best value we can. But Mike H. asked from New York State, how to make more milk, higher butterfat, and protein feeding drought-stressed corn silage. Great question, understanding that Western New York this year endured, and I think Western Pennsylvania, Northern Pennsylvania endured a pretty substantial drought. Yields were nowhere near what we were looking for, unfortunately. Well, we did end up with a crop harvested. What can we expect from this? How can we make energy and make components to keep our dairy hopefully profitable? I think back to some personal experience that I've had as a nutritionist years back when we endured a drought in the upper Midwest. Memory might be not serving me the best, but I want to think to maybe 2008, 9, 10, 11, somewhere in there. We had a substantial drought through the Corn Belt and into Wisconsin and Minnesota and Michigan. But actually, drought-stressed corn silage will typically carry considerably more energy than will that corn silage grown in ideal conditions. And speaking, maybe from my agronomy and plant breeding background, a plant that is stressed through the growing season, in particular earlier on in the growing season, will actually end up with much more digestible fiber. That plant just does not have the reserves, it doesn't have the resources to really grow strong and solidify itself and put on, unfortunately, lignin like it might in a conventional year. So we end up with quite a bit less corn silage yield, but the quality and the potential out of that corn silage we do have on a milk per ton basis is actually very good. So I can answer from, if we have at least adequate inventory to feed for the upcoming year, I expect performance to be pretty good from that corn silage, which we were seeing in the slide shown before. If, though, we do not have inventory, and the question from Mike is asking about what else could we do and how to make milk and butterfat and protein, unfortunately, we might have to feed lower forage diets, maybe decrease our starch content in the diets a little bit, and bring in some highly digestible fibrous byproduct or co-product feeds, such as maybe corn gluten feed or soy hulls or wheat midds, to offset the forage that we don't have, potentially cottonseed, to keep performance and components, and of course monitor what the cattle are doing in cud chewing to ensure rumen health. So hopefully that speaks to that question just a little bit. Then moving to looking at the Western U.S. and considering what the Western dairymen and women could expect out of 2016 forage as we get into feeding this, it looks to be pretty similar. And so to me this makes some sense. Again, at 20 pounds corn silage in the diet, 10 pounds of dry hay, we have quite a bit more irrigation taking place in the Western U.S. and the crop seems to be quite a bit more consistent. So as the crop reaches maturity, we shut the irrigation off and then we go and harvest. And it just looks like we're seeing that consistency carried through for the Western U.S. Now getting into, I guess, or continuing the interesting trend, looking at maybe some differences we've had in the Eastern U.S. in terms of the drought. Now looking at the Midwest, initially seeing 2016 forage come across this year, the early crop of hay and haylage that came through the testing laboratory was extremely high quality, and then it slipped and drifted off a bit as we got into second, third, and fourth cuts. And then early 2016 harvested whole plant chopped corn for corn silage looked to be exceptionally high quality. So as we were considering all of that together, it looks like substantially more milk, 2-3 pounds more milk in 2016 forage. But that comes with a caveat, and we're going to get into here just in a minute. Looking at September 10th. So think about, were you harvesting corn silage after September 10th? If that was the case, then I'm not exactly certain what we can expect in performance. There may not be as much wood in the fire pit, and then we may have some other challenges to deal with as far as robbing the TMR of nutrition and performance. So there's quite a bit that is still unknown here when projecting out how the TMR is going to perform. So I'll put this image now up in front of all of us and hopefully bring us all to a very real understanding for those of you that weren't harvesting within the Midwestern U.S. Unfortunately, late August and then into September, we dealt with a substantial amount of rain in precipitation, and it made for a very difficult harvest. And so my thoughts and appreciation go out to all of you that are dairying and farming within the upper Midwest that endured these challenges this fall. I so much appreciate what you do and how you all provide for all of us as consumers. But here in this picture you can see an extremely muddy field, and I stopped on the side of the road to take a picture here. This was eastern Wisconsin, and so you can see the mud on the harvester here, you can see the mud on the tractor mudding through the field, and you can see the substantial ruts that were left by the equipment. So this was the case through much of September throughout a lot of the upper Midwest, and brought some unforeseen challenges that we can explore now just a little bit as far as projecting out now how will the Midwest deal with the corn crop, or how can we expect forage to feed out. I do still have information for the eastern and western U.S., so we're not forgetting about the entire U.S. as a whole. So I'm projecting out now total moisture, or reflecting back, I guess I should say. And so when I'm whole plant chopped corn samples, or corn silage samples, you could think of them, and these are unfermented samples. So these would be ones that hit our office and were not extensively fermented. So to me, speak to what the 2016 corn silage crop will end up looking like. We have total moisture here on the y-axis between 65% moisture and 85% moisture. 65 is where I think on average our silos should be with corn, and I pose an oh no line right here, right around September 10th. And we have the Midwest represented with this red moving average. We have the eastern U.S. represented with a blue moving average, and this blue moving average is very typical, I think, thinking about prior years and what the eastern U.S. and Midwestern U.S. should look like. And then the western U.S. you see is actually much more consistent. And again, I think has to do with irrigation, or being able to control the crop moisture a bit better. So doing a pretty good job there, Western growers, as far as getting in at that 65. But what I aim to point out here is this accentuated drop in moisture as we passed mid-September. This is like nothing I've seen previously in the 10 years that I've been in the industry. So, and you can see how it's at a greater rate of decline than the eastern U.S. And so this brings considerable challenges for us. Notably, fiber digestibility, the kindling potential, if you will, of this crop will trend with moisture content, thinking about plant maturity. And so we can see at that same oh no line, this time oh no times 2, not only do we have a drier crop, which will come with challenges as far as having a good feed stability in the silo, we also really trailed off in fiber digestibility potential. We just are not going to be burning through that wood as fast, and I think unfortunately we're not going to be deriving as much energy for silage harvested after 2010, and this is going to be a considerable nutrition challenge. You can see before September 10th, for those of you that harvested there, we've actually got pretty good quality forage for the Midwest. Eastern and western U.S. trending right around average to maybe slightly above. And the goal that I see for corn silage average is 43 long-term for fiber digestibility through Professor Combs' TT and DFT. Ideally, I'd like to be up here in the 47 to 50 range, and you can see there are a substantial number of forages that are out there. So I'll challenge you all to go and find those. Cows will milk better on those. I'd like to reflect on starch digestibility potential just a bit, again utilizing the rumen in situ starch digestion tool. If we put corn grain in the rumen, silage starch, how much is digested after 7 hours? And what I'll point out here is ideally there would be 85 or greater % of starch from corn silage digested within the rumen, but as I look at in situ starch digestion ranging from really 50% to maybe 90% of starch digested within the rumen for corn silage, I'll show you 2015 corn silage, and so as we get into new crop feed, you see here the starch potential in that feed really trails off. We drop by 15, 20% in starch digestion potential. We just don't burn through this starch as fast, which pulls the energy back out of the rumen. But you can see through fermentation, and as that crop cures out, digestibility improves. So this is actually why it's important to let corn silage ferment 30, 60, 90 days if you can. You can see it took roughly until January 1st, 2016 for that 2015 corn silage to reach its potential then to feed through the remainder of the year. So then looking to 2016 corn silage, you can see the western U.S. dropped off and it has a little bit lower starch digestibility on average than the Midwest or the eastern U.S. The eastern U.S., and this may be partially the drought effect showing up. We just didn't necessarily have maybe as hard of grain as we would have year in, year out. The Midwest dropped off considerably, and we're in that period of recovery now. But I do want to point out, when looking old crop to new crop, this dip here can equate to 5 pounds of milk and performance. So that's what we're seeing there. As far as how long it's going to take us to recover, I'm not sure yet. We're sitting at mid-December here, and we're still sitting a little bit below where we had been previously. So the crop is not yet cured out from a starch digestion standpoint. Moving beyond now starch, fiber digestion, I do want to take a few slides and comment now to nutrition robbers, and I'm going to speak to yeast and mold and then mycotoxins, and we're seeing a considerable amount of these different anti-nutrition components in the feed this year that I think are coming from the field and unfortunately are going to be there for us to deal with. I want to point out long-term trends. Looking back to 2014, now this is mold and yeast counts and score scale. This is a log score of 3 versus a log score of 5. But I'd like to point out the overall trend now dating back several years. So yes, recently we have a phenomenon where we have greater mold, greater yeast levels, vomitoxin and mycotoxins I'll get into in a bit more depth here in a minute. But look at over the last 3 years now, from January 2014 to 2016, we do have increasing pressure from these anti-nutrition facets. Looking at, and I'll only stay on this slide briefly, what we've seen here now recently, looking October 1st to mid-November, we are seeing now, looking at mycotoxins, somewhere between 20%, probably 17 plus 7, that'd be 23% of feeds tested for zearalenone or above concern thresholds, upwards of 60 to 70% of feeds tested for vomitoxin are above concern thresholds for all of our locations. Breaking things down specifically into the eastern U.S. and western U.S., looking at corn silage in blue, TMR in red, corn grain in green, and then dry distillers grains in blue. I'm specifically looking at the eastern U.S. and the Midwest because it does not appear as though the western U.S. has that considerable challenge. Looking at the similar time frame, 2014 to 2016 here, and here we have vomitoxin, the concern level being then denoted by the yellow bar I have here at the bottom of 1 part per million. Of note, this is a concern level for a TMR, and that's how guidelines are written. But even at that, remembering then that the red represents the total mixed ration, you can see how over the last several years we've had bouncing back and forth between concern levels or maybe not concern levels, but here trending recently out of this 2016 corn, I see a greater frequency of sampling done here, noted by the individual dots, but then also considerable trends upward, and we see it most notably for the distillers grains. I will make mention of corn gluten feed. I did not include that within this graph, but corn gluten feed samples were also quite high. So in my mind, any corn-based feed, there may be concern as far as mycotoxin. What surprised me a bit was that the eastern U.S. also showed a slight uptick in mycotoxin prevalence, which I was not expecting. I thought this made some sense relative to the picture I showed you before and the understood challenged harvest, but I'm not sure exactly what to make of this uptick for the eastern U.S. Breaking down then and looking at beyond vomitoxin, looking at zearalenone and then T2, now focusing on 2016 to date, or January 2016 to date. Similar thought process here in terms of where our concern levels are at. Don't necessarily worry about the axes as much. These mix back and forth between parts per million and parts per billion. Understand the guidelines were written for TMR, but here our TMR are again in red, corn grain are in green, and corn silage in blue. So the vomitoxin I showed you before, again, concerning levels of vomitoxin in all of each of these corn feeds as well as the TMR, but we're also seeing upticks in both zearalenone and in T2 toxin. I wanted to pause and describe a little bit of how these mycotoxins can negatively affect animal health and performance, and they're very different. And so with this slide, I aim to show you where the mycotoxins will actually have detrimental effects on animal health and performance. So in this case, vomitoxin is depicting it can influence and unfortunately harm tissue in the large intestine. It can also interfere with rumen function, and it will also, and has been shown, to suppress the immune system. T2 shows very similar effects, although T2 seems to be a little bit more potent. Contrary to that, zearalenone, which I mentioned, we are also seeing at pretty high levels, will negatively affect the reproductive system and can challenge reproductive performance. So if, for example, we're seeing not only vomitoxin but T2 and zearalenone, I wanted to point out with this slide, or possibly fumonisins, these four toxins are just four of probably thousands that we actually know about, but they will affect the animal in different ways. So this is a very complex anti-nutrition challenge we're dealing with at the moment, and understand that just because we have measured one toxin or we're talking about one toxin doesn't necessarily mean there are other effects within the animals. Or if you're seeing some of these effects within your herd, and I've dealt with quite a few nutritionists and dairies over the last few weeks with unfortunately some pretty challenging observations or herd symptoms. If we have reproductive performance concerns, maybe look at zearalenone. If we have some rumen or digestive upset, maybe we should consider looking at vomitoxin or T2. Or if we have, unfortunately, we lose some animals and we diagnose that they died of kidney or liver failure, maybe fumonisins are what we should look at there. Beyond mycotoxins, and I think we need to be aware, but I don't also want to see us running around maybe waving the red flag. Dairy cattle are awesome creatures, and they have the ability to deal with and work through multiple stressors and multiple challenges. But I want to point out that while mycotoxins are one component of what we're seeing with this year's feed, they should only be addressed or considered or interpreted within the context of other opportunities that may be, or challenges that your farm may be enduring as well. What I mean to point out here is that nutrition will interact with the mycotoxin level in feed, which will also interact with stress. So in this case, I think about, we may have one herd or another herd, maybe two herds getting fed the same TMR. One herd may be responding, unfortunately, with clinical symptoms, whereas the other herd may not. Why is that? Both are eating the same TMR. Well, it may be due to other facets of nutrition. For example, maybe we have not less than ideal rumen starch digestion, so we have some starch actually getting into the lower gut, maybe the small intestine or lower hindgut, and being digested there, which is then maybe creating a little bit of an acidotic environment, or maybe a little bit more favorable environment for some of these tissue harming mycotoxins to have their effect. Or maybe one herd is enduring a little bit more stress, cold snaps recently, maybe slug feeding, so a little bit more stressed animal, maybe a little bit of immunosuppressant there, which then unfortunately lets the mycotoxin maybe have a negative impact. We're also starting to, from a nutrition standpoint, get into looking at enterobacteria. These would be Clostridia, Salmonella, bacteria that a healthy animal can typically fight off, but we're now seeing some of these pathogens coming in and negatively affect animals. And again, as we look at each of these individual components of your herd's nutrition program and performance, it's important to consider multiple aspects of TMR delivery and nutrition, and not just focus too much on mycotoxins. For example, think about other things that may be negatively affecting or holding your herd back as well. So I see that I'm getting up against a little bit of a time constraint here as we get towards 12:45. So I did have a few slides that we're discussing as far as looking out to the future and getting more gain, getting more milk or performance. I did have some recommendations there as far as looking at corn silage, grass, or alfalfa. I'll move through this pretty quickly, and I aim to point out that corn silage, if I want to get better corn silage looking out into 2017, I'm going to be looking at a different management strategy than I will maybe with grass or alfalfa. With corn silage, we have probably 50% of the quality we end up with is due to genotype, is due to that seed corn, whereas the other 50% is due to the growing environment. Grass and alfalfa we can influence more so with management as far as cut timing and looking at that crop physiological maturity. That's going to be a far greater impact than will the genotype or the seed variety. The variety is important, absolutely, but I would portray it's maybe only 20 to 25% of a difference there relative to if we manage the crop better or worse. Question, and then maybe we will just leave it here, but I will look to and defer to our leaders and organizers as to how we maybe want to proceed. But looking now and thinking about the genotype seed corn, how does BMR labeled corn silage through the laboratory look relative to conventional corn silage over this past year? And I put this in terms of the analogies I drew before. Does BMR have more wood in the fire pit, meaning more fiber, but less starch? Does BMR have more wood in the fire pit and more starch? Does BMR have a faster burning fiber? Do we burn through that faster? Or simply put, does BMR just look brown?
Okay, you Republicans, you got 15 seconds to vote here because we're not going to give you much time. Steve, where are you going to go?
Man, I don't know about this one. This really conventional relative.
Yeah, I'm not going to guess.
Faster,
I'm going to guess. You're going to go faster?
I'm going to go faster burning fiber. I think that's...
Well, let's close her off, Jim, and share what we have here because I think we have some data. Do we not, John?
Absolutely. So it looks like a majority of everybody has answered. We have faster burning fiber, and there seemed to be some question as far as more wood in the fire pit, maybe less wood in the fire pit, maybe there's plenty of wood and not enough starch. One of you answered it just looks brown. I can't fault you there. That is an accurate answer. So looking at brown midrib, and I'll wrap up here, here's what we've seen in 2016 for samples labeled BMR and then all corn silages that were not labeled BMR. So typically and historically speaking, there is a little bit more fiber content and a little bit less starch historically with BMR, and I've seen that across university hybrid trials, and then we've seen that here at Rock River Laboratory year in, year out. But this year, for whatever reason, maybe it was environmental, maybe it's advances in seed in breeding and technology, but there seems to be equivalent starch and fiber, which is a great thing because we also see quite a bit greater fiber digestibility in BMR. So for whatever reason, brown midrib labeled corn silage looks to be quite a bit higher nutritional value for 2016 crop. And again, this is different than we've seen in years past, where the energy levels look to be a little bit more similar because of that fiber versus starch offset. But this year, BMR looks to be a pretty high quality feed. Can't speak at all to the agronomic characteristics and traits, but I wanted to throw this out for a little bit of controversy as well. So in the interest of time, guys, I think I'm going to skip past maybe the next content. I had a little bit as far as high cutting theory. This came from an article wrote for Hay and Forage. I'll point you to that in the August 2016 issue there if you'd like some detail there. And then I also had some projections to look at how management can affect whole farm, or at least whole acre economics, but I'll invite you to look at that within your slide deck and maybe reach out to us after the fact and we can answer some questions there, or maybe get into it now. And then I'll wrap up with my contact information and we'll get to the final slide here. And I welcome any conversation today or after the fact, and appreciate the opportunity to contribute today.
Well,
Okay. Go ahead, Mike.
Nope, go ahead, Steve.
Well, thank you, John Gaser, for a very interesting presentation. Lots to think about, good data, and some good real-world observations combined that I think I'm hoping that our many participants found of interest and help. So we want to thank you most sincerely. Appreciate your presentation. We also want to thank QLF for their sponsorship of the webinar today. Looking ahead at our schedule, January 9th, Dr. Jeff Stevenson from Kansas State University will be updating us on some reproductive strategies to getting cows getting pregnant sooner, sponsored by Parnell. And then looking just a bit further ahead, February 13th, we're going to be taking an in-depth look at National Milk's F8 RM program, and Emily Stepp will be making that presentation, and we're certainly looking forward to that. That's an important program for our industry's image and humane treatment of our cows. Also want to take this opportunity to thank Jim Baltz, Mike's partner down there at the University of Illinois, Patty Hirchin up here on our staff, for her support. And of course, always Mike for his co-hosting responsibilities. In a couple of days, those of you that were with us today, we had a nice group of you. You'll be receiving a survey. We appreciate your response on that, and helps us keep our webinar series focused. And if you have any friends, colleagues, co-workers that wonder how come they haven't heard from Forage Dairyman lately regarding webinars, it has been necessary for people to sign up. Obviously, you folks have, to re-sign up, I should say. Obviously, you folks have, but there may be some others who have not. So, with those comments, Mike, do we have some questions for John?
We sure do, John. Get ready. John, can you click to the next PowerPoint? We want to make sure we give ample exposure to our hosts, because without our hosts, as Steve points out, we're in real trouble here. A general comment, one of our listeners said, third crop seems to have more fiber relative to the first and second crop in the Midwest. John, any comments about that?
I think that would fit with what I have anecdotally experienced in working with nutritionists and producers. The year in the upper Midwest was quite variable depending on where one is at with timely or untimely rains coming in. The first crop was, generally speaking, extremely high quality, and with that first cutting driving a lot of the yield for the year and a lot of the forage that I think is on your dairies, the first crop was high quality. But then as we looked out to second, third cuttings, potentially third and fourth cuttings, we had, from remembering back, pretty reasonable growing conditions. And I've had some suspicion as well that we've got wonderful alfalfa genetics that may be growing and maturing at faster rates than they would have previously. So speaking of a third crop that had a bit more fiber relative to the first and second, I could understand, and I have seen some of that, although I don't know that it was the average.
John, one of our listeners also observed that the total track NDFD in all three regions of the United States is lower in corn silage compared to our hay and haylage. He was surprised in seeing that, thinking that the corn silage fiber digestibility was that much lower. Any comments on that, even though the level may be lower?
Yeah, that's a great question. So understanding really what potential there is in that corn stover and in the whole plant, the corn silage, we've historically thought of corn silage as really great feed relative to hay and haylage. In many cases, as we've fed more corn silage in diets, cattle performance and health has improved. But I don't necessarily think that's due to the fiber. I think that might be due to a little bit more digestible non-fiber component in this starch, and then likely a little bit more consistent feed as well. What Professor Combs has seen in total tract digestibility in comparing diets that are fed heavily corn silage or a blend of corn silage and alfalfa or grass, and then maybe more grass and alfalfa, is that they're very similar in fiber digestibility, which may be, I guess, confusing depending on what metrics you've been looking at in the past for assessing fiber digestibility. But I think that's true. And as far as recent corn silage trends being a little bit lower than hay and haylage, that fits with, I think, what we've seen over the last few years. We've had pretty good growing seasons within the upper Midwest and eastern U.S., especially last year. Pretty good season where it carried through. It might have been a little bit longer getting that crop off than would have been ideal. And then especially this year, we had tremendous growing conditions and exceptional yields, as I understand, in both grain and tonnage. Unfortunately, it was mired in a little bit of a quagmire in monsoon, getting it off in the upper Midwest, or dealt with a little bit of drought to the western New York, western Pennsylvania, eastern New York, eastern Pennsylvania, maybe a little bit different scenario there. So with, in my mind, a higher tonnage, maybe a little bit stronger crop when the growing season permits, will lend itself to a little bit less fiber digestibility because that plant lignifies a little bit more, and it needs to add some structure to then hold up a big old ear. And that grain yield, as we hear accounts of 2, 3, even 400 bushels per acre out there. So I think it makes a little bit of sense that the corn silage fiber digestibility may be a little bit off this year relative to hay and haylage.
John, another question. Looking at your DON information, it was interesting to see that the corn grain had a modest increase in DON coming through your labs, but boy, the distillers grains, and you said corn gluten also jumps right up there. Does that reflect handling characteristics or storage? It's got to come from the corn, or is it just a concentration effect that's going on? Any thoughts on that?
I think it's probably a concentration effect, as well as maybe some of the toxin coming from the field. I don't think there is a mycotoxin jump or an increase in mycotoxin just due to how those products are handled, but rather I think it's a concentration of the mycotoxins that are present in feed, because as starch is removed in either the ethanol process or in the wet milling process, the toxins are associated with the seed coat and in the soluble fraction of the feed that's left over, and that would then be represented by our distillers grains, our corn gluten feed. And I'll throw caution out there, any corn-based feed, unfortunately, it looks to have a little bit higher mycotoxin level this year, or even over the last few months. And speaking to distillers, it wasn't really until we got into November where we started to see really concerning levels of mycotoxin within distillers grains, and that may correspond to the new crop then coming into our ethanol plants. It didn't track with what we were seeing in vomitoxin increases in corn silage as the samples came through, where we started to notice those as early as September and October. We did not see distillers trending up at that point. It was a month or two later.
Very good observation. Another question just came in. Are you seeing starch digestibility lagging a bit for this time of the year? And you already point out it comes in beginning next year. His question, or her question, was maybe the kernels seem to be drier and dried down quicker in the east. Do you think under the drought conditions, do you think that could be a factor?
Yeah, possibly. So I'll just speak based upon experience here, as I'm still, and I think we as an industry have quite a bit to learn as to the environmental and even agronomic factors that will influence both fiber and starch quality. But if the plant dries down quicker, particularly if we get past ideal silage maturity and grain maturity, and I'll make a point that whole plant moisture and grain maturity don't always go hand in hand. In some cases, we can have grain maturity advancing faster than what it appears silage moisture and silage maturity to be. But if we have a drier grain as we move from, say, 75% moisture to 55% whole crop moisture, and as that grain matures, what holds starch digestion or starch potential back is a little protein cage that builds around the microscopic starch granules. And I don't mean to get too much into the detail, but as that grain matures, which corresponds to the grain drying out, which it speaks to the question here, that protein cage builds stronger and stronger and stronger and makes it that much more difficult for the rumen and the rumen microbes to access starch. So if we had a faster drying plant, if we had a faster maturing corn grain that got beyond the ideal maturity that we'd like to see within our feedstuffs, yeah, then that would speak to and would be in agreement with a lesser starch digestion, and is one thing that we're seeing right now in general that is also bringing challenges in alongside the mycotoxins. We just aren't getting the rumen digestion potential that we should be, and then you couple that with maybe a little bit of pathogenic or mycotoxic potential in the feedstuffs, and unfortunately some herds are being stressed considerably, and it's a little bit of a challenge to build out of.
Okay, John, here's your last question so far, and then maybe another one pop in, and that has to do with the cost of testing for mycotoxins. Can you give us a rough idea about what the typical cost for a mycotoxin test is? And then part two simply says, well, should we be testing only suspected feeds, or what about sampling the feed? Is there a problem in getting a good representative sample to send to your lab?
Yeah, great question, and this is a really difficult one to dance around, and I think first and foremost, to understand what the challenge is at hand, or what maybe better termed would be the opportunity for the dairy. So if we just have a bit of concern level, animal health and performance doesn't maybe indicate there's anything holding us back, in that case I would suggest starting with the total mixed ration, being a blend of all the feeds. And I understand the challenges that come with sampling a TMR, but work with your consulting team to take the absolute best TMR sample that you can, and start with a vomitoxin assay. Vomitoxin, working with Professor Whitlow in the past, I've learned can be a decent marker for us in identifying mycotoxic load. And in that circumstance, for a matter of about $50, we can get a vomitoxin analysis on a TMR and generally understand what the opportunity might be, or if we have something that we should be concerned about. However, if we have some clinical symptoms, variable digestion, a little bit looser manure, maybe inconsistencies on farm, drops in performance, changes in components, maybe unfortunately if we lose a few animals, then all of a sudden we may be a little bit more aggressive in our sampling, understanding that we can invest a little bit to hopefully recoup some of the lost performance. There are a little bit bigger dollars at play. In those circumstances, I still advise working with the TMR, because that's what's being consumed, and that's should be a reasonable blend of everything. One could look at doing individual feeds, but then the price point can jump up considerably. I would start with the vomitoxin and zearalenone and a T2, given that those are the three that we seem to be quantifying at a little bit greater levels and greater frequencies this year. There are also 12, 16, 19, and 37 toxin panels out there that will do a little bit more of an exhaustive mycotoxin investigation for us. Sometimes it can be overwhelming, but in cases where we lose considerable performance or profitability and potential, a $200 to $300 analysis is pretty small relative to some of the dollars at hand, hundreds to thousands that we're talking in performance. So to answer the question again, testing costs ranging between $50 for the bare minimum, or the simplistic approach upwards of $300 for a comprehensive and expanded approach. And I recommend starting with the TMR and then working backward from there to identify suspect feeds if the TMR suggests, yes, we do have a concern level.
Well, Dr. John, you've done an excellent job. Steve, we'll let you finish up.
Thank you, Mike. Again, thank you, John, for a wonderful job, and thanks to Quality QLF for their support. I want to call your attention out there to the next webinars we have coming up. Reproduction, January 9th, Jeff Stevenson. Parnell sponsoring. February 13th, the National Milks Farm Program by Emily Stepp. We look forward to having you with those and all future webinars, and we're glad that you were with us today, and we look forward to having you back. And that's all from Fort Atkinson, Wisconsin today.